a translation is a transformation that slides each point of a figure the same distance in the same direction. And once you get to the new location, you create a new image. So in other words, if I give you an example, I can have a line that looks like this. So let's say I have 1, 2, 3, 4, 5 points on that line. And if I slide that line to a new place, let's say if I slide it to here, so I have 1, 2, 3, 3, 4, 5. So I simply was sliding the black line to the right, looks like by 3 units, and then downward looked like about 2 units. So the new image that's created in the blue looks like this, should be exactly, I know it looks silly, but it should be exactly in the same shape, same measure as the black line. They're exactly identical. And we call this blue one a new image, an image. We use when we refer to the old one as a figure or a diagram. Okay, so whenever we talk about an image, we're referring to the new image. In our example is the blue line. So you can do the same with triangles. You can have a triangle looking like that, and you simply move each of the 3 points by the same distance in the same direction, and then you should have a new triangle that looks a lot prettier than my awful triangles there. That looks terrible. Okay, but you got the concept. So this whole process is called a transformation. Basically, you are mapping a figure onto a new image. So let's do some practices. Look at the first one. The lighter gray truck on top, and then that truck got moved to the bottom. So we have to decide if this is a translation. And the answer is yes, this is a translation because the orientation has not changed. In other words, all we did, this is the orientation has not changed. So all we did was we took each point of the gray truck and moved it downward a little bit and then rightward towards the right side a little bit. We didn't do anything else. And then that fits the vocabulary that we just learned, right, about translation. B, we've got the black truck and the gray truck. They're flip-flopped. So in this case, this is not a translation because look, the orientation has changed, right? So the definition of translation is simply you slide the figure either upward or downward to the right or to the left, but you don't change the orientation, okay? So obviously the third one, for the same reason, the third one is not a translation because also the orientation has been rotated 90 degrees and it has changed. Let's look at this example here. It says, describe the translation of the segment. And the segment is PQ, which is right here. And it also gave us the coordinates for both P and Q, 2, 4, and 1, 2. So let's look at P. To go from P to P prime, we need to move the units, we need to move the point 4 units to the right, and then 2 units down, right? And for Q, in order for Q to go from here to here, we have to go to the right first by 4 units as well. And then we go down by 2 units. So in other words, every point on the segment PQ are moving 4 units down, and are moving 4 units to the right. So 4 units to the right and 2 units down, from 4 to 2, from 2 to 0. So that's it. We just described the translation. Every point on segment PQ moves 4 units right and 2 units down. That concludes that. Now, how do we describe that in a more mathematical way, in a generalized format? So let's look at example 3. Here we have a point, and the point is right here. It's not very easy to see. And then we have to move that point to this new point, A prime, right there in blue. Okay? So to get from point A to point A prime, I have to move 3 units to the left. Is that, yep, 3 units to the left. See the 3 here? And then after I move to the left, I can move up by 4 units. So 4 units to the right. I'm sorry, 4 units up. 4 units up. Okay? So then to write that whole paragraph, remember I mentioned that mathematicians are lazy people. They tend to use symbols to represent language rather than spell out every word. They use this notation. They use coordinate x, y is transformed, right here, is transformed into x plus a and y plus b. So in other words, if a is our coordinate, the coordinate for a is x, y. So what is the coordinate of a prime? And like we said, a prime is, it has to be x plus a, but in order to find what a is, we moved a to the left by 3, so that's negative 3, right? So in other words, if I take x, in this example, x is 4, I move it by 3 units to the left, I have to minus 3, that's how I end up with 1. Right here. And then for b, I have to take the y coordinate. In this example, y is 3. I move up by 4, so that's how I end up by 7. So my b is 4. And if I have to generalize this, is xy is transformed to x minus 3, y plus 4. Again, this is the part that we call the new image. Here's some checkpoint practices. Make sure you complete that. If you have questions, stop in and ask me. Let's look at, I believe this is the last example for this unit. Draw the triangle with vertices A, B, C with all the coordinates provided. Then draw the image of the triangle after the translation given by xy is transformed to x plus 2 and y minus 3. So we have to draw the vertices first. If I have negative 2 and 5 is here, and 0, 7 is here, so this is B, this is A. C is 3, 7, so 1, 2, 3, 7 is there, so this is C. Ooh, not the easiest thing to draw on an iPad with glass. Then I have to draw the image of the triangle after the translation, given that, look, I'm moving my x coordinates to the right by 2 and y coordinates downwards by 3, right? So so that's 2 units to the right, and minus 3 is 3 units downward, go south. So let's see how we do that. If we take A, move plus 2 will be on the y-axis, and then downward by 3, that becomes 2 here. So this is my A, I should do a different color. This is my A prime. And I do the same thing with B. B is 0, 7, 0 minus 0 plus 2 is 2, and then 7 minus 3 is 4. So 2 and 4. It's right there, right? So my C is 3, 7. 3, 7, if I plus 3, that would become 5. 7 minus, I'm sorry, plus 2 becomes 5. 7 minus 3 is 4. So I would have 5, 4. 4 is here. So now I have my A prime, B prime, C prime. Okay, again, all I did was based on this formula, I went back to my original coordinates, and then I took each x and y here, and for all the x, I just added 2. So you can even just do it this way, and this would be 5 here. And then for the y, I subtracted 3. So that's how I end up with my new coordinates. This would be 4. And this is C prime. So that's how I ended up having A prime, B prime, C prime. And as you can tell with my terrible artistic skills, they don't look exactly alike, but if you can do a better job, that's what it should look like. Okay. Oh, I'm sorry. The reason that it doesn't look exactly the same is because I got the coordinates wrong. So this one is here. Oops. Come on. 1, 2, 3. C prime is there. I didn't get the... There. Much better. That makes me a much better artist. There. At least I can draw a triangle with straight lines. There we go. That looks a little bit better, right? So I hope that that makes sense. If it doesn't, make sure that you come and see me. Follow up. I cannot stress how important it is to finish this. Think through this problem slowly. It's tedious, but it's not that hard. Checkpoint. These are yours to complete. Okay? See you in class. Bye.